In this lesson, we're going to define the trigonometric functions for three special angles: 30 degrees, 45 degrees, and 60 degrees. It's important that you understand some of the basic concepts about triangles before you view this lesson. You should know that the sum of the angles in a triangle is 180 degrees. You should know that an equilateral triangle has three equal angles, and those angles equal 60 degrees, and it has three equal sides. That a right triangle has two acute angles, and their sum is 90 degrees. And you should know that an isosceles right triangle has two legs that are equal, and the two acute angles equals 45 degrees. If you've forgotten these concepts, you might want to view a previous lesson. Now let's look at an equilateral triangle and look at the measure of the sides and see how we can determine the trig functions of a 60-degree angle and a 30-degree angle. First, we start out with an equilateral triangle. It measures 2 on each side. We know because it is equilateral that each angle measures 60 degrees. The next thing that I did was I took this and I bisected this triangle from this vertex to this base, and when you bisect an equilateral triangle like that, then what is formed is two right triangles. I bisected it so that this line was perpendicular to the base, as noted by the squares that tell us that these two angles are the right angles. Of course, this side is the same as this side. It still measures 2. This is the hypotenuse for this left-right triangle. And then this side is the same as this side, so it measures 2, and it is the hypotenuse for this right triangle. Let's look at the bottom legs for each of these triangles. Since I bisected this base, when I cut 2 in half, this leg equals 1 and this leg equals 1. Now what we want to do is to find the measure of this leg. I will call that leg A, and we can use the Pythagorean theorem, which says to square that hypotenuse and subtract from it the other leg squared. 2 squared is 4, subtract 1 squared is 1, so we get that the measure of that other leg in each triangle is the square root of 3. Now the last thing I want to do is to label the angles. This angle is the same as this angle, so it measures 60 degrees. Since I bisected this 60-degree angle, this angle will measure 30, and this angle will measure 30, and because this angle is the same angle as this angle, it will measure 60. So what I've got formed here are two right triangles. We refer to them as 30, 60, 90-degree triangles. Now I'd like to label just one of these triangles. So let's see here. My hypotenuse is 2. My 30-degree angle is up here. My 60-degree angle is down here. Across from my 30-degree angle, the measure of the leg is 1, and the measure of the leg opposite the 60-degree angle is the square root of 3. So we will take this triangle and figure out, using our definitions of opposite, adjacent, and hypotenuse, the 6 trig functions of 30 degrees. We're going to define the trig functions of 30 degrees in terms of the opposite leg, the adjacent leg, and the hypotenuse. So let's look at that triangle and label those things for the 30-degree angle. All right, we already know that the hypotenuse, I think I'll abbreviate, equals to 2. The leg opposite 30 degrees equals 1. And the leg adjacent to 30 degrees equals the square root of 3. And this would be true for our 30-degree angle. So when we find the sine of 30 degrees, we define it as opposite over hypotenuse. It would equal 1/2. And let's go ahead and define its reciprocal. The cosecant of 30 degrees would equal 2 divided by 1, which of course is just 2. When we find the cosine of 30 degrees, it equals the adjacent leg divided by the hypotenuse. So that would equal the square root of 3 divided by 2. And let's go ahead and find the secant of 30 degrees, the reciprocal of the cosine, 2 divided by the square root of 3, and then we'll rationalize, and we'll get 2 times the square root of 3 divided by 3. Last, let's look at the tangent of 30 degrees. It's equal to the opposite leg divided by the adjacent leg, so that would be 1 divided by the square root of 3. Let's rationalize, and we get the square root of 3 divided by 3. For the cotangent of 30 degrees, we'll use the reciprocal of the tangent. Now, we could use the reciprocal of the square root of 3 over 3, but we know that the square root of 3 over 3 is just the rationalized version of 1 over the square root of 3. So for our purposes, it would be easier just to find the reciprocal of 1 over the square root of 3, which is the square root of 3 over the 1, and of course we don't need to write the 1. So here are your 6 functions of 30 degrees, and I will summarize those in a chart after we've found the functions of 60 degrees and 45 degrees. Now we want to take that same triangle and find the functions of 60 degrees. Let's start with a new triangle. It will be the same one. We'll label the parts. Our hypotenuse is 2. This acute angle equals 30 degrees. This one measures 60 degrees. The side opposite 30 is 1. And the measure of the side opposite the 60-degree angle is the square root of 3. Now, let's label for the 60-degree angle. Well, of course, just for the triangle, the hypotenuse equals 2. But for the 60-degree angle, the side that is opposite the 60-degree angle measures the square root of 3. And the side or the leg that is adjacent to the 60-degree angle measures 1. So when we define the sine of 60 degrees, it equals the opposite divided by the hypotenuse. We get the square root of 3 over 2. For the cosecant of 60 degrees, we use the reciprocal of the sine. We get 2 over the square root of 3, and we'll rationalize. We'll have 2 times the square root of 3 divided by 3. For the cosine of 60 degrees, we use the adjacent leg divided by the hypotenuse, so it will equal 1/2. the secant of 60 degrees will equal the reciprocal of 1/2, which is 2. For the tangent of 60 degrees, we'll use the opposite divided by the adjacent, which would just simply be the square root of 3 divided by 1, which is the square root of 3. And for the cotangent of 60 degrees, we'll use the reciprocal of the square root of 3, which is 1 divided by the square root of 3, and we want to rationalize that. We'll get the square root of 3 divided by 3. Now, let's look at another triangle and let's find the functions of 45 degrees. We'll look at an isosceles right triangle to find those functions. For an isosceles right triangle, we know that both legs are equal. I've chosen them to equal 1. We also know that the measure of each acute angle is 45 degrees. So the only thing we need to do here is we need to find the hypotenuse, and since we have the 2 legs, we'll just call the hypotenuse C, as is customary for right triangles. And we know to find the hypotenuse, we'll say 1 squared plus 1 squared, which of course gives us 1 plus 1, or the square root of 2. So let's just label that as the square root of 2. And it really doesn't matter here which of these angles we use. Let's use this 45 degree angle. We know, of course, that our hypotenuse equals the square root of 2. And if we choose this 45 degree angle, the side opposite it is 1, and the side adjacent to it, the leg adjacent to it, is also 1. So, of course, our opposite is going to equal our adjacent, because we know that opposite and adjacent are legs, and that the legs are equal in an isosceles right triangle. Now, let's define our trig functions for 45 degrees. The sine of 45, we'll take the opposite and divide it by the hypotenuse. We'll rationalize, and we'll get the square root of 2 divided by 2. For the cosecant of 45 degrees, we could find the reciprocal of the square root of 2 over 2, but because this is just the rationalized form of 1 divided by the square root of 2, once again it would be easier for what we want to see to use the 1 divided by the square root of 2. So the reciprocal of 1 over the square root of 2 is simply the square root of 2 over 1, and of course we don't need that 1 in the denominator. For the cosine of 45 degrees, we'll take the adjacent, which is 1, we'll divide it by the hypotenuse, and obviously that's the same thing as the sine, isn't it? And so its reciprocal will be the same thing as the cosecant. And let's look at what happens when we find the tangent of 45 degrees. The tangent is opposite divided by adjacent, which would be 1 divided by 1, which is 1. And then the cotangent would be the reciprocal of 1, which is also 1. So there are the 6 trig functions of 45 degrees. Now, I've summarized this in a chart. Notice that this is labeled exact function values of the special angles, you will learn to calculate the trig functions of your angles. And of course, when you use a calculator, when you come up with something like the square root of 3/2, it gives you a decimal value that you have to round, and when you round, that is an approximated value. So when we ask for the exact values, we are talking about these fractional values where we leave the radicals. So it's important in your class to note whether you need the exact values or whether you can calculate them and round them. You need to copy these down. You need to learn these. You need to know these without your calculator, without the chart. And the easiest way to do that is to learn the sine, the cosine, and the tangent of the three angles, and then of course use your reciprocals for your cotangent, your secant, and your cosecant. Now let's look at some problems, and there is really not too much to these problems. What you're supposed to do is to memorize those functional values of those special angles, and then for most of these problems you're just supposed to know the answer. So let's look at them. It says give the exact trigonometric function value. Do not use a calculator. Well, for the cosine of 60 degrees, we're supposed to know that the cosine of 60 degrees equals 1/2, and just write 1/2. On the second one, for the sine of 45 degrees, we're supposed to know that the sine of 45 degrees equals the square root of 2 divided by 2, and just to write the square root of 2 divided by 2. On the tangent of 30 degrees, we're supposed to know that the tangent of 30 degrees equals the square root of 3 divided by 3, and just write the answer. Now, on problems 4 and 5, those are reciprocal relationships. So when they ask us for the cosecant of 30 degrees, we're going to think first we're supposed to know what the sine of 30 degrees is, and of course the sine of 30 degrees is 1/2, and then we're supposed to know that the cosecant of 30 degrees is the reciprocal of 1/2, which of course would equal 2. And on the cotangent of 45 degrees, we're supposed to know that that equals to the reciprocal of the tangent of 45 degrees, and then we're supposed to know that the tangent of 45 degrees equals 1, so the cotangent of 45 degrees would be the reciprocal of 1, which is of course 1. One of the other skills that we're supposed to be able to perform after we've studied this lesson is if we're given one of the sides of a 30, 60, 90 degree triangle, we should understand the relationships in the sides, and we should be able to find the other two sides. Also, for an isosceles right triangle, if we're given one of the sides, we should be able to find the other two sides. So let's look at the relationships in the sides of these triangles. Let's go back to our 30, 60, 90 degree triangle. Let's label a new triangle. We'll let the hypotenuse equal 2. We'll label 30 degrees, and the leg opposite 30 degrees is 1. We'll label our 60 degree angle, and the leg opposite our 60 degree angle measures the square root of 3. Now, as it turns out, for a 30, 60, 90 degree triangle, the leg opposite the 30 degree angle will always be half of the hypotenuse. Or you can think that the hypotenuse will always be twice the length of the leg opposite the 30 degree angle. For the leg that's opposite the 60-degree angle, it will always be equal to the leg across from the 30 times the square root of 3. For example, if this was our triangle with our 30-degree angle there and our 60-degree angle there, if the side across from the 30-degree angle equals 7, then the hypotenuse would be 2 times 7, or 14, and the leg opposite the 60-degree angle would be the square root of 3 times 7, or we would write it as 7 times the square root of 3. Now, in my opinion, it's easier to find the hypotenuse and the leg opposite the 60-degree angle if you're given the side across from the 30-degree angle first, but that's not always the case. So we have to understand, if we're given the hypotenuse, how to find these two sides, or if we are given the side across from the 60, how to find these two sides. So I have written these in rules for you. The easiest to find will be when you are given the side opposite the 30-degree angle, and that was the one that I just gave you. To find the hypotenuse, multiply the side opposite the 30-degree angle by 2. To find the side opposite the 60-degree angle, multiply the side opposite 30 degrees by the square root of 3, and that's what we just did. Now, look at what happens if, instead of being given the side opposite the 30 degrees, what if we're given the side opposite the 60 degrees? And of course, we'll want to find this leg and the hypotenuse. And let's just pretend like that maybe we're given that this leg measures 4. Well, what I do is I set up an algebraic equation. I know that this side, which I will call side A or leg A, that's across from the 30, I know that if I take A and if I multiply it by the square root of 3, I'm going to get the side across from the 60. So to figure out what A is, I divide by the square root of 3. And so the leg across from the 30 equals 4 divided by the square root of 3. Now you know we're going to rationalize that. So we'll say 4 times the square root of 3 over 3. So now look what I did to the leg across from the 60 to get the leg across from the 30. I took it and I divided by the square root of 3. So if I'm given the side opposite the 60, what I do first is I find the side opposite the square root of 30. And the way I do that, to find the side opposite the 30-degree angle, not the side opposite the square root of 30, excuse me. If I'm given the side opposite the 60-degree angle, to find the side opposite the 30-degree angle, I divide the side opposite the 60-degree angle, that was the 4 in this case, by the square root of 3. Now, once I have the side that is across from the 30, it's fairly easy to find the hypotenuse, because remember how I do that? Look right back up here. Once I have the side opposite the 30, to find the hypotenuse, I multiply it by the square root of 3. I don't know where my head is today. I multiply by 2. So I would take the 4 times the square root of 3 over 3, and I would multiply it by 2. That will give me my hypotenuse, which I will label as C. And so when I multiply 4 times the square root of 3 times 2, I say 4 times 2 is 8 times the square root of 3 over 3 times 1 is 3. So my hypotenuse in this case would be 8 times the square root of 3 over 3. And there's the rule. To find the hypotenuse, multiply the side opposite 30 degrees by 2. Now the last example dealing with a 30, 60, 90 triangle that I'd like to look at is one where you're given the hypotenuse. So suppose we're given the hypotenuse. Well, if I'm given the hypotenuse, I first find the side across from the 30 because I think it's easier to do that. So let's pretend like that the hypotenuse maybe is a 5, and let's label my 30-degree angle and my 60-degree angle. Well, now, what do I know the relationship is? I know that the side opposite the 30 degrees is half the hypotenuse, don't I? So this leg A will be 5 divided by 2, and that's how I find the side opposite the 30-degree angle. I divide the hypotenuse by 2. Now once I have the side opposite the 30-degree angle, I can find the side opposite the 60-degree angle. Remember what the relationship is? What do? I multiply by the square root of 3, and I'll write that over 1. I'll have 5 times the square root of 3 divided by 2. So to find that side opposite the 60-degree angle, multiply the side opposite 30 degrees by the square root of 3. Now let's look at the relationship in the legs and the hypotenuse in an isosceles right triangle. We'll start with the legs 1, 1, and of course we found that the hypotenuse was equal to the square root of 2 in an isosceles right triangle, and of course we know this angle is 45 and this angle is 45. Always in an isosceles right triangle, if you know the length of one leg, then you know the length of the other leg, and the length of the hypotenuse is equal to the leg times the square root of 2. So if this is my isosceles right triangle, and I know that this length is 3, then I know this length is also 3 because the legs are always equal. And I know that the hypotenuse is 3 times the square root of 2 because the hypotenuse always equals to the leg times the square root of 2. So let's look at those rules. In an isosceles right triangle, if you're given a leg, to find the hypotenuse, multiply the leg by the square root of 2. That's the example that I just gave you. And of course I didn't write how to find the other leg, but the other leg is just equal to whatever the length of this leg is. Now what if you're not given a leg? What if you're given the hypotenuse? Well, let's pretend like my hypotenuse is 8. Well, what I know is that, let's call this side A or leg A, and of course this is leg A also because they are equal. There are a couple of ways I can find this. I know that if I take the lag and multiply it by the square root of 2, I'm going to get the hypotenuse. And so to figure out what the lag is, we'll divide both sides by the square root of 2, and we get A equals 8 divided by the square root of 2. Now, of course, we have to rationalize that, which will give us 8 times the square root of 2 divided by, let's see, when I rationalize, I need square root of 2 over square root of 2, don't I? And when I multiply square root of 2 times square root of 2, I get 2. And then, of course, I can reduce the 8 over the 2. The 2 divides into 2 once and into 8 4 times. So I get that the lag is 4 times the square root of 2, which, of course, means that this leg measures 4 times the square root of 2, and this one does also. Now look at what I did though. I was given the hypotenuse. How did I find this lag? I took the hypotenuse and I divided by the square root of 2, didn't I? And so that is what you do when you're given the hypotenuse. To find the lag, divide the hypotenuse by the square root of 2, and then of course once you've found one lag, you know the other lag. Now let's apply these rules to two problems. Okay, for this first problem, we're asked to find the exact value of each labeled part. Now, notice what I have here. I have a right triangle. This angle measures 30 degrees. Here's my right angle. And so, of course, this angle right up here measures 60 degrees. I'm asked to find this length, which is called A, this length, which is B, and then I have another right triangle right next to this one. The difference is, though, that for this right triangle, and I couldn't fit it in there, this angle is 45 degrees, which, of course, what does that make? That angle right there, well, it's also 45. And so then I'm supposed to find the hypotenuse here, and I'm supposed to find this leg, which is leg D. So let's see what I have to work with. What I have in this 30, 60, 90 triangle is that the hypotenuse is 7. The hypotenuse is 7. So for my 30, 60, 90, I know that the hypotenuse is 7. Now I think it's much easier to find the leg that is opposite the 30 degree angle. So which leg is opposite the 30 degree angle? That is B, isn't it? Now, do you remember how we find the leg opposite the 30 degree angle when we're given the hypotenuse? We take the hypotenuse and we divide it by 2. So I know that B is 7 divided by 2. Now that I have the side opposite the 30 degree angle, I can find the side opposite the 60 degree angle, which is side A or leg A. And how do I do that when I know the length of the leg across from the 30? I take the length of the leg across from the 30 and I multiply by the square root of 3. So leg A equals 7 times the square root of 3 divided by 2 times 1, which is 2. Now, let's find C and D. I know that B is 7 halves. And for this second triangle, B is one of the legs across from one of the 45 degree angles. So then I know what D is, don't I? Since this is an isosceles right triangle, this leg has to equal this leg. So I know that leg D equals B, and I know that leg B is 7/2. Now let's find the hypotenuse here. C is the hypotenuse. How do I find the hypotenuse when I have the leg in a 45, 45, 90? I take the leg and I multiply it by the square root of 2. So this hypotenuse in this second triangle equals 7 times the square root of 2 over 2 times 1, which is 2. So I've found the labeled parts, side B, side A, side D, and side C. Now let's look at this second problem. I couldn't fit the label of the angles on the inside, so I just wrote them on the outside. This first triangle, this angle is 45 degrees, which of course, what does it make this angle? It makes it a 45-degree angle, so this is an isosceles right triangle. And then for this second little triangle, this angle right here is the 60-degree angle, which of course makes that angle measure 30 degrees. Let's look at the isosceles right triangle. We're supposed to find the hypotenuse, which is T, one leg, which is S, and one leg, which is Q. Let's look at the 30, 60, 90 degree triangle. We know that one leg is 5. The leg opposite the 60-degree angle is 5. We need to find R, which is across from the 30-degree angle, and S, which is the hypotenuse for this triangle. So let's find R first. R is across from the 30-degree angle. And how do we find the side opposite the 30-degree angle when we know the side opposite the 60-degree angle? We take the side opposite the 60-degree angle and we divide by the square root of 3. So that will give us the side opposite the 30-degree angle, which I choose to find first. I just think it's easier. Let's rationalize, and we'll get 5 times the square root of 3 over 3. Now, how do we find the hypotenuse? Notice that S is the hypotenuse for the 30, 60, 90 triangle. It is a leg for the 45, 45, 90, isn't it? But we're going to find it thinking of it as the hypotenuse of the 30, 60, 90 because we know what the side across from the 30 is. How do we find the hypotenuse when we know the side across from the 30? What's the relationship? The hypotenuse, S, is twice the side across from the 30. So let's take the side across from the 30 and let's multiply it by 2. 5 times the square root of 3 times 2, we say 5 times 2 is 10. So we'll have 10 times the square root of 3, and 3 times 1 is 3. So now we know what S is. What else do we know? Well, since this is a 45, 45, 90, when we know S, since it is a leg, we also know the other leg, which is Q. So Q equals 10 times the square root of 3 divided by 3. And the last thing we need to find is T. T is the hypotenuse, isn't it? And how do we find the hypotenuse when we know one of the legs in a 45, 45, 90? We take the leg and we multiply by the square root of 2. So when we have 10 times the square root of 3 times the square root of 2, that equals 10 times the square root of 6, we know we multiply the radicands. The square root of 3 times the square root of 2 is the square root of 6. And then in the denominator, 3 times 1 is 3. Now, if we had a common factor for 10 and 3, we could divide out that common factor, but we do not. So I think we've found the things that we need to find for this last problem. R, 5 times the square root of 3 over 3. S, 10 times the square root of 3 over 3. Q, 10 times the square root of 3 over 3. And last, T, 10 times the square root of 6 over 3. You'll have to practice how to find those sides in those 30, 60, 90 degree triangles and in the isosceles right triangle. But after some practice, you should be able to do that. This completes this lesson. Please rewind the tape before you return it. Thank you.